All right, baby. Looks like we're live. So we're gonna continue on with the Raza Learning Chemistry series. We're at chapter 3.5, Empirical Formulas from Analysis. So just remember, I do all the work. All I gotta do is just follow along, or even just hear it out through the audio. But if you have any questions, or if you're taking an exam and this is exactly where you're at, I'll answer your questions and all that shit. All right. So, anyways, let's keep going. So, empirical formulas from analysis. As we learned from section 2.6, the empirical formula for a substance tells us the relative number of atoms of each element it contains. The empirical formula uh, H2O shows that water contains two hydrogen atoms for each oxygen atom. The ratio also applies for the molar level. 1 mole of H2O contains 2 moles of hydrogen atoms and 1 mole of oxygen atoms. Conversely, the ratio is a number of moles of each element in a compound. In a compound gives the subscripts in a compound empirical formula. In this way, the mole constant provides a way of calculating the empirical formulas of chemical substances as shown in the following examples. Mercury and chlorine combine to form a compound that is 73.9% mercury and 26.1 chlorine by mass. That means that if we had a 100-gram sample of the size sample, it would be used. Oh, wait. Sample of solid, it would contain 93.9 grams of mercury and 26 grams of chlorine, Cl. Any size sample can be used in problems of this type, but we will generally use 100 grams to simplify the calculation by mass from percentage. Using the atomic weights of the elements to to give us smaller masses, we can calculate the number. All right, let's go down. All right, so this is what they got: 79 grams of mercury, and then I guess that's the mole. The how many grams equals 1 mole, and that's he got the moles. All right, let me get my notepad out real quick. I wonder what happened to the physics shit. Oh, anyways, fuck it. So, anyways, this is where we're at the chemistry. So let's just get started. So what they're saying is they have 73 grams. Oh shit. I can't even write. Hold on, guys. Fuck. All right, so you got 73.9 grams of mercury. And if you look at the periodic table, mercury is gonna weigh 200.6 grams for 1 mole. All right, of Hg, which is mercury. That's gonna equal 0.368 moles of Hg. All right. So that's all they're doing. All right. And then since this is the percentages, see that's the percent turned into grams. The remaining percent is 26.1 grams of Cl. And you basically do the same thing, 35.5 grams. So if you look at the periodic table, go look where chlorine's at. That's how you got this number right there. And that's going to equal 1 mole. And then when you multiply the top and then divide by all the numbers in the bottom, you'll get 0.735 moles of Cl. All right. Fuck it. That's all they're doing. That's all they're talking about. All right. So anyway, let's keep going. When we divide the larger number of moles of 73.5 by the smaller 0.6 to obtain a ClH mole ratio of 1.99 to 1. All right. Moles of HCl. Okay, so what they're doing is all right, so what they're doing is they're grabbing the numbers that we got over here. See that? So they grabbed those numbers and they did a bigger one on top. Okay. So they went 0.735, right? See that shit? Moles of Cl over 0.368 moles of Hg. Okay, so this is what they did. And when you divide this number by this number, you'll get 1, right? You see that? So divide every number. See that? Divided by 0.368 divided by 0.368. See that? That's going to give you, oh shit. That's going to give you a ratio of 1 right here at 1 point, what was it? 99. See that? That's a ratio, okay? And then you're going to get a 2 to 1 ratio. And that's really important because then that's going to tell you that, which is on top. Oh, so it's going to be 1. Hold on. It was Cl at the top or hold on. Well, fuck it. Well, let me tell you what it means. All right. So you get the 2-to-1 ratio, and then you have mercury, which is HgCl, right? So this is the 2 choices of mercury, right? So what does a 2 mean? 1, it's either going to go here and the 1 right here, or it's going to be 1 right here or 2 right here. The reason I lost is because I think I got my units wrong. Hg is 1. Yeah, okay, so Hg is 1. Okay, there you go. That's the proper units right there, okay? Hey, Filthy Rich, what's up? Hey, bro. Oh shit, hold on. Oh, there you go. I was trying to highlight your comment. Hey, bro, thank you for joining, bro. All right, so I feel like I'm just talking to myself, and thank you for joining, bro. So anyways, what we're doing a little bit of the chemistry work right here. So if we look at the book, oh shit, let me pull up the book real quick. So if you look at the book, they got this number right here, and then I'm going up ahead, and I'm showing you the significance of the numbers. So if you look at right here, it's like a 2-to-1 ratio, a 2 on top and 1 in the bottom. And when you go see, sir, let me pull up this window. All right, there you go. And then when you get that 2-to-1 ratio, you see how in the book it's 2-to-1. See that ratio? It's 1.999 over 1. So that's what that means when we look at the formulas. So it's either going to be one of those two, but since I know the what's he said, the metal, mercury is 1, so I know this is the right one. Bam. All right. And this one does not exist in nature. All right, at least not in that form. You know what I mean? It might exist as like a 4. Wait, hold on. It might exist as a 2, but the chlorine has to be a 4. Hold up. The chlorine has to be a 4. It might exist like that, but when you put it down at its basic form, you'll really end up this one in nature. All right. This one might exist, and they might even go higher. It might even go like just keep the same ratio, 3 to 6, right, or some shit like that. See that? Just keep the same ratio. But now you're just in the world of mathematics. Now you're just doing math. You're not really doing because when we do experiments in the lab, expect only this shit to be real. All right. But that's the difference between math and physics, or chemistry, right? Um, in math, you can just keep adding shit. All right, so let's keep going. Okay, let's go. Because of experimental errors, a result may not lead to exact integers for the ratios of moles. The number of 1.999 is very close to 2, so we can confidently conclude that the empirical formula for the compound is HgCl2. All right, so that's the second one we chose right there. All right, only in the book. Oh shit, I'm not even showing you shit. All right, only in the book. You know how my answer over here was H1Cl2. All right, that shit. And what the book says. What does the book say? All right, there you go. The book says it's HgCl2, which it means the same thing. All right. Uh, 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 uh. The empirical formula is correct because the subscripts is the smallest integers that express the ratios of the atoms and the compounds. The general procedures of determining empirical formula is outlined in figure 3.1. So make sure the integers or the nearest whole number, all right? Mass percent elements, assume 100-gram sample. I don't know. You guys could look at that shit if you want. All right, so calculating the empirical formula, ascorbic acid. All right, we're just gonna do this one. Man, it's kind of hard to see all that shit. All right, so ascorbic acid, vitamin C contains 40. Hold up. Contains 40%. 40% carbon. Oh shit. 40.92% carbon and 4.58% hydrogen and 54.50% oxygen by mass. All right. So what is empirical formula of ascorbic acid? All right. So all we got to do is just change those into decimals. All right. So let me just erase the percent. So I'm assuming I just have 100 grams of this shit. So from 100 grams, no matter the percentages, it's going to be that whole number right there. You see that? All right. So now take the smallest number, which is a hydrogen. Wait, hold up. Yeah, you can take whatever number. Fuck it. So anyway, let me just do this real quick. That's the carbon. I'm gonna try to solve all of them at the same time if I can. All right, so carbon weighs what? 12? 12.1. I'm not gonna solve it in a calculator, guys. Equals 1 mole. All right. Hydrogen is 1.00. Oh, grams. My bad, guys. And that equals 1 mole of hydrogen. And then over here, I know oxygen is 16. And then equals 1 mole. All right. Bam. All right, equals 1 mole. So if you divide this, damn, I don't have a calculator. That's what sucks. Let's look what let's take the books. Oh wait. I did the problem right here on the side of the book. All right, so on this one on my book, I put 3.33. So if you do it in the calculator, 3.3, some shit like that, and then I got 3.4, some shit like that. Hold on, let me see. My numbers are all messed up. 4.54. Hold on, guys. Let me rewrite these numbers. This is not what they equal. This is why I wish I had a calculator on me, and I don't. All right, hold up. Hold on, let me use my other phone as a calculator. Hold up, guys. You know what? Let's just go off what the book says. Fuck it. I don't like doing it like that, but I wish I had an answer. All right, so for the carbon, it's gonna equal to 3.4. All right. For the hydrogen is equal to 4.54. And this one's gonna equal to 3.406. You see that? Yeah, perfect. All right. So now what do we do? So now we get these numbers on the side. Oh wait, hold on. This one was like 07 or some shit. Hold on. Yeah, 07 and 06. All right. So you get these numbers, right? So you have these numbers right here. All right. So you're gonna get the smallest one, which is this one. I know it's just smaller by a 0.00 something. All right. So that's oxygen. All right. So, but hold on. First, let me write carbon is what 3.407. Hydrogen is 4.54, and then oxygen is what 3.406. All right, so now I'm gonna divide by the smallest number there is, which is this guy right here, by oxygen. All right, divided by 3.406. Divide the carbon by 3.406 also. All right. and this is going to give you another number. So on this one, it's going to be 1, obviously, because these are equal. These ones are so close that I'm just going to call it 1. I know it's going to be 0.0000 something, but the closest number is 1, right? And then on this one, it's going to be like 1 point, uh, oh, hold on. I don't know what the answer is. Like 1 point something something. 1.3. You see that shit? Okay, now I get it. Now I get it. All right. So you see how we got 1.13? All right. See how this number is not really a whole number? We're going to have to make that into a whole number. Hey, Coral Works. What's up, G? I'm kind of going over the chemistry and trying to remember at the same time. All right. So you see this number? Uh, since I felt I was talking to myself, but I'm glad you guys are here. All right. So you see this whole number right here? This number is not a whole number. We had to multiply it. Hold on. All right. We had to multiply it by at least 3, right? Times 3. See that shit? To get a whole number, which is gonna be what? Hold on. 3 times 1, which is gonna equal to 1, right? Oh wait, hold up. I don't have a calculator on me, guys. Hold on, let me get my other calculator. Let's just cheat real quick. Ta-ta-ta. Yeah. Wait, what the fuck? All right, fuck it. All right, so we multiply that by 3, right? And then we're gonna have to. I don't know what the number is. All right, and then we're gonna have to multiply this by 3, and then this by 3. And what that looks like in fraction, and like if it's a fraction, let's say we kept this as a fraction instead. What that's gonna look like is gonna be hold on. Uh, it's gonna be 1. What the hell am I talking about right now? Oh yeah, 1 times 3 for that, and then 1.3 is equal to, see, 1/3 times 3, right? And then over here is gonna be 1 times 3. So why is this 1/3? Because that is the same thing as that shit right there. You see that? These two mean the same thing. All right. That's why I converted. So when you multiply this by the third, you're gonna have the third in the bottom, which is gonna equal to 1. See that shit? But that's why I know that's the equivalent. But anyways, let's just get the fucking answer. All right. All right. So when we multiply this by 3, you're gonna end up over here with 3 for carbon. Hold on. With carbons, you're gonna end up with a 3. The hydrogen, like I said, I wish I had a calculator, but 3. All right, so multiply this, that's gonna be a 3, and that's gonna be the 1. So that's gonna equal to 4. And then oxygen, and it's gonna be 3. So let's clear that up. All right, you see that shit? So that's where we're at. So we got carbon is 3. Let me rewrite these again. So we go on the next slide. All right, see that? All right, bam. All right, so what does that mean? So remember the formula was CHO, right? Or they only gave us a percentages. All right, they only gave us the percentages, but now we could fill these up. So this is gonna be 3 for carbon. Hydrogen, if we did it right, it's gonna be 4, and then oxygen is gonna be 3. All right, and this is based on a sample that was what, 40. That was 40.92% carbon. Hydrogen was 4.58, and then oxygen was 54.0% by mass. All right. So out of 100, all right. So that should be the final answer, but let's go look at the fucking book because we got the book right next to us. Next time I'm gonna bring the calculator, guys. My bad. Yeah, C3H40. Okay, perfect. Hold on. All right, now let's do another one. My bad, guys. Hopefully, I don't blind you guys. Okay, perfect. This one's gonna be a tricky question. All right, so right here where it says practice exercise, so I'm gonna write and talk at the same time. All right. All right. So the question is I'm gonna read the question first and then solve it and then write it down. A 5.35 gram sample of methylene benzoate, a compound used to manufacture of perfumes, contains 3.758 grams of carbon, 0.316 grams of hydrogen, and 1.251 grams of oxygen. What is the empirical formula of the substance? All right, so let's go look at that shit out. All right, so on this one, I obviously don't have the math for it, but fuck it. All right, so we got a 5.325 grams of methylene benzoate. I don't even know what the formula. I'm just gonna call it MB, just because I don't know how to pronounce. Methylene benzoate. I'm not gonna be writing that shit. To manufacture perfumes that contains 3 point. Remember, just write down all the numbers. 3.758 grams of carbon. You know what? I'm just gonna write a C for carbon. All right, for carbon, and 0.316 grams of hydrogen, and 1.251 grams of oxygen. The empirical. Okay, so those are all the numbers we got, right? So hold on, I'm trying to think of something real quick. All right, fuck it. Let's just keep going. All right, let's just solve what we know. Be like, hopefully we run into the right answer. It's like we're taking an exam and haven't even studied. All right, so carbon. I know carbon is 12. So 12 grams of carbon is equal to 1 mole. So 1 mole of carbon. And then for hydrogen, I know hydrogen is 1. So equals 1 mole of hydrogen. And then oxygen, I remember is 16 grams. Remember grams, guys, is equal to 1 mole of oxygen. So this is going to give me a percentage. All right, man, I don't have a calculator, guys. I don't know if I should just go off what I used to have in my old book. Hey, what's up, Rainer? Thank you for joining, bro. We're here solving the chemistry and on the spot too, fucking live, baby. All right, so I don't have a calculator, but let's see. Man, hold on. Let me use my other phone. I need to get a calculator, guys. My bad, dude. This is slowing the fucking process and shit. God, I think I need to download the app too. Hold on. Oh man, that does suck. I do have to download a calculator. Hold on. At least on the other phone. All right, 3.7. Okay, yeah. On the book, I messed it up. I'm looking at my old notes. I messed up the initial amount right there. It's not 3.58. Oh wait, it is. No, never mind. I'm fucking up right now. Live. 3.758 divided by 12 is equal to 31. All right, fuck it. This is what happens when you don't have a book. So it's gonna equal to. I'm just gonna go with my old notes say. And if I'm wrong, correct me, guys. 31.13 something something. And then on this one, 0. Is going to equal to, for the hydrogen, it's going to equal 0. You know what? Fuck the 0. I didn't put it last time. 0.3 16, and then for the other one, I got 0. Oh wait, 0.078 something something. All right. Hey, do you need a calc, bro? I can mail you one. I have some from school. Oh shit, Cole works. Thank you, bro. I would feel weird asking for a calculator when I could just go buy one, bro. But yeah, bro. There's a specific calculator that I really like using. Um, I could write down the whole thing, but sorry guys, it's that I'm using the app, and the app really sucks to do calculations and shit. Oh shit. All right. But anyways, let's keep going. All right. So we got that number right. So now let's divide that number by the nearest whole one that there is. Uh, all right. Yeah. Perfect. Let's go. I'm right. All right. So let's divide by the smallest number. All right. Which is the oxygen. So we're going to divide every single number by this. All right. So what's that going to look like? Hold on. So that's going to equal to 3. Oh, shit. For carbon, it's going to equal to 0.313 divided by, oh, you know what? Let's do it this way now. 0 0.78, and then for the hydrogen, it's going to equal to 0.316 divided by 0.078, and then the oxygen is going to equal to 1. All right, there you go. All right, so oxygen is equal to 1 because it's it's divided by itself. All right, so that's why it's equal to 1. All right. So from this, let's see what that equals. I don't have a calculator, guys, but all right, I don't have a calculator, but based on my notes, if you divide this number by that number, you're gonna get a number close to 4.005 or something like that. I'm not sure. And then on the hydrogen, you're gonna get 4.04. I don't know if that shit's right, but fuck it. All right. So you get 4.04 and you get 1 right here. All right. You see that shit? So what does that mean? So carbon is going to equal to 4, and then hydrogen is equal to 4, oxygen is equal to 1. And what does that mean? So if we get the compound or the whole shit, you're going to get C4. You know what? Let me write it over here so it looks nice. You're going to get C4, H4, and then oxygen is 1. I don't give a fuck. I write it out. You don't need to have that 1 right there. See that? You don't need to have that 1, but I'm going to keep it on there. All right. So this should be the final answer. All right. And then if we look at the book, they don't do the work for us, but they at least they give us the answer. See if we're doing it right. There you go. There you go. The answer is C4H4O1. You see that? So it looks like we did do it right. And another thing that I want to point out, you see this initial amount that they gave us? Initially, hold on, where's that? All right. So you see this initial amount that they gave us? That shit does not mean anything. All right. Because we're basing off everything being 100 grams. So if you want to find out exactly how much oxygen and all that shit you have, okay. So now you got the formula, right? You got that. And they gave you 5 point, what is it? 325 grams of C4H4O. All right. So now you could go from moles to whatever you want. You see that? But uh that initial amount is just there to confuse you. This initial amount is there to confuse you, okay? You don't need that shit, okay? That's why I say write down all the numbers and see what you really need and discard what you don't, because they will fuck you up like that. And the reason you don't really, oh, the reason you don't, okay, there's another thing. The reason I just said fuck it, because I assume everything's out of 100 grams. So even if they do have this amount of grams in there, I kind of really wouldn't care. But initially, I just wrote, oh shit, my camera's out. My bad, guys. But initially, I caught myself on that. That's why I was like wondering what the fuck. Hold on, guys. My camera's down. I know you guys can still hear me, but give me a sec. Well, I'm trying to get my camera working. Let's catch up on comments. I gotcha. We all have our preferences. Thank you, bro. I have the Casio scientific calculator and the formula buttons are all in the wrong places, and I have it. And I hate it. Oh, you hate it. Oh, I gotcha. I like my Texas Instruments calculator. Oh yeah, that's right. Like I said, I think the Texas instrument I like is a TI 32, some shit like that. We'll look it up right now. But I really want to get my camera working. I wonder if I need a new battery on the camera. That sucks. Hold on. Because they broke my cord that I had for the camera to just attach it directly to the power outlet. Wait, hold on, guys. This ain't cool. All right, no, the power is on. My bad, guys. Hold up. I wonder if my computer froze. Hey, could you guys hear me still? Let me know. Unless my computer froze. Oh shit. No, we're still good on the computer. All right. Hold on. Why is this ain't working though? Hold on, guys. Let me switch the battery on my camera real quick. Hold on. Sorry, yeah. People broke my cable and now I have to use my old batteries on my actual camera instead of just actually using my wall straight into the camera. All right, hold on. Okay, that one's dead too. Hold up. I got 3 of them, so I know I was charging 2 of them. What the fuck? Come on, work. My bad, guys. You know what? I might just use my old setup. I might use my nephew's cord for his fucking video game. Yeah, fuck. Hold on, guys. Let me get my nephew's cord for his video game. Hold on. Thank you guys for waiting. I'm setting up my nephew's, grabbing his power cord. Someone broke mine. I don't know what the fuck. And I'm using it to use it as a power supply to my camera. Hold on. Hopefully it's not too many volts and watts and all that bullshit. All right. Oh, perfect. All right. So my nephew's gaming cord to the rescue. All right. Thank you guys for your patience. Hold on. All right. Bam. All right. So I forgot what I was talking about, but yeah, we're done with the problem right there. Now let's keep going. And thank you guys for joining, honestly. Yeah, we're almost done, guys. I hope. Fuck. I'm looking at all the problems we got to do. All right, there you go. All right, so molecular formula from empirical formula. All right, for any compound, formula combined from percentage composition is always an empirical formula. We can obtain the molecular formula from the empirical formula if we are given the molecular weight or molar mass of the compound. The subscripts in the molecular formula of a substance are always a whole number multiplied by the corresponding subscripts on its empirical formula. Section 2.6. The multiple can be found by comparing the empirical formula by weight with the molecular weight. Whole number multiple, molecular weight, empirical formula weight. All right, let's just keep going. In a sample exercise 3.13, an example of an empirical formula of ascorbic acid is determined to be C3H4O3. Given the empirical formula weight of a determined molecular weight is 1.6 atomic mass units. This molecular weight is 2 times the empirical formula weight. 176 divided by 88 equals 2. And the molecular formula must therefore have twice as many of each kind of atom as the empirical formula. Course, consequently, we multiply the subscripts by empirical formula by 2 to obtain the molecular formula C6 C6H8O6. So what the fuck does that mean? So remember I was telling you guys earlier that if we need to multiply, oh fuck, I don't know. Well, if you need to add more ratios to this shit, oh what the fuck? If you need to add more ratios, make sure you add them as whole numbers. You see that? Oh shit. All right, make sure you keep just going as a whole. But anyways, fuck all that shit. All right, determining molecular formula. Oh man, mistylene, something like that. A hydrocarbon that occurs in the smallest amounts in crude oil has an empirical formula of C3H4. The experimentally determined molecular weight of the substance is 121 atomic mass units. What is the molecular weight of mesothelene or some shit like that? All right, C3. I'm trying to see this shit real quick. You know, let's just read what it said. But let's keep going. Solution. We are given the empirical formula, the molecular weight, and asked to determine the molecular formula. All right. The subscripts for the molecular formula of compound are a whole number multiplied by the subscripts of empirical formula. To find the appropriate multiple, we must compare the molecular weight with the formula weight and empirical formula. First, calculate the weight of the empirical formula. All right, so let's write down everything we know, and then we'll go. All right. So we know C3H4. All right. And then what we're gonna do, we're gonna separate these into the carbon. All right. So this is gonna equal to the carbon. I don't know if I should write a C. Fuck it. You know what? Hold on. A C for carbon. Right? You see that? And carbon has 3, so I'm gonna write that 3. Okay. See what I'm doing? And then the oh shit. What the fuck? All right. And then carbon weighs 12 grams in the, what do you call it, in the periodic table. All right, that's where I got that 12. All right, so this is all I'm doing. See that? Carbon, and carbon weighs 12. See that shit? All right, plus now we do the same thing but with the hydrogen. All right, fuck, this is gonna suck. H4. Oh wait, hydrogen has 4 right here, right? I'm getting that 4 from right there. I'm just putting that number, this hydrogen, so you can know where it's coming from. Okay, and then multiply. Hydrogen weighs 1. All right. Okay, see that? So we got that 4 from right there, the 3 from right there. 12 is the weight of carbon, and 1 is the weight of hydrogen. Okay, that see that shit? All right, so now let's go back. All right, so now 3 times 12, I think that shit's 40. I don't know why I wrote 40, but I have 40 right there. And then 4. Okay, now I know how I got 40. It's 40, these two together. All right, see that shit is equal to 40. And then they gave us the atomic mass units that was given, which is 100 and what was it? 121 AMU. So atomic mass units is equal to that. All right. You see that shit? So now what we could do is get the 40 or the 121. See this shit right there? 121 AMU divided by the 40 from right here. And then that's going to equal I'm getting 3.025 based on my notes. All right. You get this number right here. All right. C3. All right. All right. Okay. There you go. So what does that 3 mean? All right. You see how this is the smallest we got, and then this is the total that they gave us. When we get this 3, what that means, see how we're dividing everything by 3? That 3, we're going to eventually take it and use it to multiply the top shit right here, the subscript. Hold on. To multiply this number right here, those two numbers. All right, so let's clear that up. What does that look like? So you get the carbon times 3.025. So you can see what I'm doing. And then the hydrogen, 4. Bam. All right. So now we cleared it up. All right. So now we get this number right there. You see that? Now we're going to multiply the 3 and that 4 right there. And we're going to get C9 and H12. Bam. Is that it? I wonder how, like, is that it? Yeah, that's it. I'm overthinking this shit. All right. Bam. That's the final answer right there. I'm overthinking this shit. All right. So let's go back. Let's go back. What the fuck did I do? You know what? Let me redo it. Let me redo this whole shit again for you. So you know what the fuck happened. So you got the C3H4, right? And then I'm gonna break this up into the carbon. See, so this is gonna be a 3 and carbon. Oh fuck, you know what? Fuck that. 3 times 12 is a carbon, right? And then right there, we got this 4 right here. So 4 and hydrogen weighs 1. Okay. The only reason I remember those numbers is because I use those numbers a lot, guys. All right. That's the only reason. Hold up. That's the only reason I remember, because I use these numbers a lot. So I remember. You're going to have to look these numbers in the periodic table. Okay. So now we're at. All right. So you get those numbers, right? And then when you add them, right, you're going to get 40. All right. And then they gave us the atomic mass unit of this one, which was 121 AMU, right? So then I get that number, the original number they gave us, and divide that by 40. And we're going to get 3.025 or some shit. Let me write it neater. All right. And this number right here, the 3, is what we're going to use to multiply this number right there. See that? And what that's going to leave us off with is a C, and 3 times 3 is 9. And hydrogen, 4 times 3 is 12. And then you left off with that right there. Simple as that. All right. And that's the final answer, actually. All right. Hold on. Let me write something. this is what we had. The C3. I wrote this in my notes. What was the hydrogen original for? There you go. That's all I did. So this is the number they originally gave us, the C3 and the H4. But we solved all that shit just to get that. All right, just to get this. But anyways, let's keep going. Oh man, they got a practice one right there for us, and we have a huge audience right now. Holy shit! Thank you guys for joining on this fucking chemistry shit. You don't know how bad I feel like skipping this, guys, so I don't have to do it. But what's the point of me skipping if we're not taking shortcuts here? All right, let's go to the practice exercise. So this one is not gonna have us like simple, beautiful shit. We're gonna have to really work out this problem. All right, but at least they gave us the answers. Okay. So, anyways, ethylene glycol, the substance used in automobile antifreeze, is composed of 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen by mass. The molar mass is 62.1 grams per mole. What is the empirical formula of ethylene glycol? And B, what is the molecular formula? All right, so first off, let's write down what the fuck we know. All right, so we know there's carbon, and we know there's hydrogen. Oh shit. And we know there's oxygen. Okay, because those are the three atoms or molecules they gave us, right? And that makes up antifreeze. And by now, let's actually plug in the numbers. So we got 87. Oh wait, my bad. 38.7% is carbon, and 9.7 is hydrogen, and then oxygen is 51.6%. All right. So what do we do now? All right. So we're gonna assume we have 100 grams because por cien, is por cien is 100, right? So if this is a percentage, we're just gonna assume this is in grams, and now we could have 37.8 grams instead. See that instead of a percent. So these two mean the same shit right there. All right. So what does that mean? In short, I'm just gonna delete the fucking percentages right there. See that? Bam. So instead of percentages, now I'm gonna put grams. Okay, see that? A G for grams. All right. And then next up is, because I know, just because I know, we're gonna have to get the molar ratio. So we got to convert everything into this shit called moles. So how do we get the moles of carbon? Easy. So you look in the back, or no, actually, yeah, it's either in the front or the back of the book where you have your molecular weights at, or the periodic table, and the periodic table has all the weights for you. But I memorized mine. Well, not just because I work with these molecules, I remember. But carbon weighs 12 grams of carbon is equal to 1 mole. The real answer is like either 11.9999 or like 12.0001 or some shit like that. You know what I mean? But just based off of my memory. All right, and then hydrogen. Oh shit. I'm not doing this shit without even showing you guys. All right, and then hydrogen. Hydrogen. See how? Damn, I feel like I fucked it up for you guys. Fuck it, we're just gonna keep rolling. Hydrogen. Remember, this grams was originally percentage. I just changed out to percent. All right. Why? Because no matter what, we're gonna assume 100%, and 38.7% is gonna equal to the grams. You see that? All right. So, anyways, so hydrogen is equal to 1 gram. Hold on. It's like 1.00 something grams is equal to 1 mole of hydrogen. And then oxygen, oxygen weighs 16. Yeah, oxygen weighs 16. And then that's equal to 1 mole of oxygen, hydrogen, carbon. Okay. And then the numbers I got, you're going to have to divide these numbers. All right. So divide the 51.565 or whatever. Oh, yeah. 51.6 divided by 16. Okay. Uh, the number I got in my book, I got 3.225. And then on the other one was 9.7. And then on the other one was 3.225. Okay. And you might look, oh, how do they get these numbers so exact? that's the beauty about learning chemistry, is that they're gonna give you perfect fucking numbers. Okay. What do I mean by that? You're gonna divide everything by the smallest number, which these two are equal. All right. So you're gonna divide everything by the smallest number. All right. So this is gonna equal to 1. Hold on. This is gonna equal to 1. Obviously, that's gonna equal to 1. All right. But then you have 9.7 right here divided by the 3.225, and that's going to equal I got 3.0007, some shit like that. Which it really, you don't really need to, because 3 and there's a 9. You know what I mean? All right. So we got this ratio of numbers right here. You see that? Oh, fuck. All right. So we got that ratio of numbers. And from right there is we're going to take the C, the H, and the O, and we're going to plug in those numbers. So 3, so 1, you see the carbon? Oh, what the fuck? Oh, shit. All right, so you see that 1 for the carbon right there? I'm going to put a 1. And then the hydrogen, you see the 3 for hydrogen? I'm going to put a 3. And hopefully this shit's right, guys. All right, 3. And then oxygen, 1. Bam. See that? 1 right there. So that's my final answer. I think. Hold on. Oh yeah, it is kind of my final answer. It's almost my final answer. All right, so we got this number right. So now let's hold on. I'm gonna write this number right here. C1 H3 oxygen 1. All right. Bam. Okay, so we got this formula, right? But then they gave us the AMU, right? Which was given. Okay, the molar mass is 62.1. Wait, I shouldn't put an equal sign there. Oh, yeah, fuck it. Grams per mole. All right, so they gave us this number, right? 32.1. All right, so now what we want to do is, you see the carbon? We know we're just going to get these ratios. All right. So carbon is what? Carbon is 12. So what we want to do is, we have 1 carbon. See that? 1 carbon, and carbon weighs 12. Plus we got 3 hydrogens, right? And hydrogen weighs 1. And then oxygen, we only got 1 oxygen, and oxygen weighs 16. All right, you see that shit? So when you add these numbers up, you should get 31. You should get 31. All right. And then that 31, what we're going to do is take this 31 and divide it by this number right there. All right. which I'm wondering how I'm gonna do this. I'm just gonna take that number and divide that 31 literally right there. This is what beautiful. That's what's beauty about math. You can just put brackets in that bitch or parentheses. All right. So what is that? What does that look like? It's gonna look like 62.1 divided by 31. All right, and then that's gonna equal to a number, which is what, 2? Because 31 times 2 is 62. See that? So this 2 right there is really important. All right. So now we get that original formula that we got. C1H3O1. Remember, this formula is the one we got earlier from right there. See that? From right here. You see that? That's the one we calculated. All right. Oh shit. Yeah, so we're right there. All right. So you see that formula right here? So now we can get this 2 and multiply it by all the little shits right there. See that? And what's that going to equal? It's going to equal to C2H 6. Yeah, 3 times 2 is 6. And O2. See that? And that should be my final answer. Unless I fucked it up somewhere. Oh, yeah, that is the final answer. All right, so now let's compare with the book. Let's compare what the book says. All right, see how the book says CH3 CH3O. All right. And then on the one right to the next. Okay, hold on. Let's fucking compare. All right, so you see how it says CH3O? It's the same thing to what we wrote on our shit. Hold on. Oh, you can't see my phone through here. See where I'm at on my phone? Okay, can't see through there. All right, you see how right here, see what I'm writing right here? You see how that's equal to 1? All right, on the book, if we read it, it's C1H3O1, which is the same thing that we got over here, which is, hold on, let me write it for you. This is how they write it in the book, CH3O. That's how they wrote it in the book. All right, which means the exact same shit. These two mean the exact same shit right there. That they mean the exact same thing. All right. And then on part B of the problem, it's C2H6O2, which is the same thing that we got right here. See that? So it looks like our answer is right. All right, guys. And that's how you solve this problem right there when you don't have anything other than just the answer at the end. Okay. We solved that shit. So next problem. Let's keep going. Damn, this is a lot of work, guys. But I do wish I had a calculator. I'm gonna get a calculator, just like a simple one, just so I could at least put plus, minus, divide, multiplication, all that bullshit. But anyway, let's keep going. Combustion analysis. The empirical formula of a compound is based on experiments that is given the number of moles of each element in a sample of the compound. The word empirical means based on observation and experiment. Chemists have devised a number of experimental techniques to determine empirical formulas. One technique is combustion analysis. Is commonly used for compound techniques. Is compound analysis commonly used for compounds containing principally carbon and hydrogen as their component elements. When a compound containing carbon and hydrogen is completely combusted, it in an apparatus such as shown in figure 13.12, the carbon in the compound is converted to CO2 and the hydrogen is converted to H2O. Section 3.2. So basically, this is a little thing. Basically, what it's saying with carbon and hydrogen is that anything that will burn with carbon and hydrogen is going to produce chemicals and shit that their detectors could detect and shit like that. Anyways, let's keep going. The the amount of CO2 and H2 produced is determined by the measurement of mass increase of the CO2 and the H2O absorbers from the from the masses of CO2 and H2O. We can calculate the number of moles of carbon and hydrogen in the original compound, and thereby the empirical formula. If a third element is present in the compound, its mass can be determined by subtracting the mass of the carbon and hydrogen from the compound's original mass. Sample exercise 3.15 shows how to determine the empirical formula of a compound containing CH and O. All right, so what the fuck did I just read? All right, so if you burn something like sugar, sugar contains a lot of carbon and hydrogen. Let's say somehow you're able to burn sugar, you're gonna get something that's gonna absorb the CO2 and the water, okay? And when you take the measurements of how much these two gained, you can subtract it by the third absorber and get the remaining chemical. That's what they're saying. But it's just different ways to get uh like the whole C3H4 and all that bullshit down, okay? From just experiment. So when you're doing chemistry, you got to think about see this, you guys just see this little shit, but or you just see numbers, but you have to think of it as if you're the one doing the experiment yourself. So let's go to the next one and see what we're talking about. Damn, that's a long ass fucking problem. That's gonna suck. All right, fuck it. All right, so isopropyl alcohol. I can't read for shit. A substance sold as rubbing alcohol. See, you get rubbing alcohol is composed of CH and O. Combustion of 0.255 grams of isopropyl alcohol produces 0.561 grams of CO2 and 0.306 grams of H2O. Determine the empirical formula of isopropyl alcohol, whatever the fuck. All right, so if we look at the problem over here that we did earlier, guys, remember I told you it was kind of information you didn't really need? This is when we're really are going to need it when you have an unknown amount. It might give us an unknown amount. You want to subtract your knowns from the unknown original, okay? But we don't need to do that over here. Even though right here I kind of caught myself because I just saw that the numbers were kind of close. But anyways, fuck it. That's some other shit. Let's just go to the problem. Let's see how much more I got to do on this shit. Okay, we're almost done. I think this is the last one. Yeah, baby. Hold on. Okay, so 2 more problems and we're done. All right. So thank you guys for being right here, guys. And like I said, even if you have the answer, none of that shit matters if you can't get to it. All right. So let's go with what we know. So we know rubbing alcohol has. Oh, let me get my little screen this time out. Hold on. I'm not sure what do you guys want to see more. Hold on. Fuck it, we'll just go like that for now, and then I'll switch it. Okay, so rubbing alcohol has carbon, hydrogen, and what was oxygen, and let's say if it would have had a third or fourth element in there, it would just keep adding it. Okay. All right. But let's go what we do know. Combustion of 0.255 grams of alcohol I'm just gonna put CHO, okay? Produces 0.561 grams of CO2. All right, and 0.306 grams of H2O. Ah, fuck, man. This sucks. All right, so what do we want to do first? We're told the isoprene contains that much amount. Hold on. Because I'm wondering when they subtract the actual thing. All right, fuck it. Let's just go with what we do know, guys. All right. All right. So this is the total. Thank you guys for watching. See, you guys watch me do chemistry in the spot. So all my fuck ups and all that shit, you guys are gonna see it live. So let's just go with what we know. So let's get the big screen out. Fuck it. So you guys can see me. All right. So what we do know is we got CO2 and carbon, right? Right here. So let's work with that and this number also. So let me get those two numbers. And then we'll come back to over here, okay? All right, so let me write that number down real quick. 5.56 grams of CO2, right? And then we got 0.306 grams of H2O. All right, so we're gonna go with what I do know. So all right, so this is what we're gonna try to determine, guys. So O2, okay, so this is gonna be real confusing. All right, what I'm about to say. So you see how there's oxygen in this side? You're gonna very well confuse it and add it to this oxygen right there. But like I said, in reality, you got to think of this oxygen came from the air, and so too did pretty much everything else. All right, so you got to distinguish what we're gonna solve for first. All right, so what do I mean by that? Let's just fucking keep going. Okay. Hey, Big MF, thank you for joining, bro. Aquatic Amigos, thank you for joining. G, thank you guys. Honestly, man, it makes me actually want to continue doing what I'm doing because I feel like a retard sometimes just talking to myself on the camera. All right, so we got this. All right, so first off, we got grams. So I want to convert grams to moles. So carbon weighs 12 and oxygen is 16, and we got two of those. So what's 12? Well, 16 times 2 is what, 32 plus 12. We're at what, 44, I think. If you guys let me know if I'm doing it right. So 44 grams of CO2 weighs 1 mole. Oh, gives us 1 mole of CO2. And then 1 mole of CO2 has 1 mole of carbon. Oh, fuck. Has 1 mole of carbon, right? Damn, guys, I might have to delete the other one real quick. Oh, I can't even delete it. Fuck. Shit. Hold on, guys. My bad. You know what? Now I know what to do. Hold on. Okay. It goes 1 mole of carbon. I'm just going to continue on where I'm going. And then 1 mole of carbon weighs 12 grams. All right. and then 12 grams of carbon, and then that's gonna equal. Fuck. Now I wish I had a calculator. Shit. I wonder if damn, my work's way too confusing over there too. All right, fuck it. All right, guys, this is how you're gonna have to solve this shit. I'll help you out. So you're gonna get 56 or 0.056. If you guys have a calculator, help me out. Times 12 divided by 44. So we're gonna have to plug in that number on the calculator real quick. And I don't even got one. Hold on. 56 times 12 divided by 44. 56 times 12 divided by 44. Hold on. Hope I remember that shit. What was it? 56 times 12? Was it? Divided by 44 equals 15.27. All right. So it's equal to 15.27 grams of carbon. Well, I'm just going to put a C for carbon. All right. Grams of carbon. Okay. So from the first one, remember these. Oh, shit. Yeah, fuck it. What was the number? 12 point what? Oh, 15.27. Sorry, guys. I'm trying to keep track of this shit, and it's really hard for me. All right, 15.27 grams of carbon. All right, bam. So we solved for that. And now we got to solve for hydrogen. Okay, which is going to equal this right here. And remember, this oxygen came from the atmosphere, okay, or wherever the fuck it came from, right? Don't worry about that shit, because we're gonna get the carbon and the hydrogen, and then subtract it from this one over here, or actually from this amount right there. Oh shit! All right, so now we got it. Solve for 306. Oh, cool. What is it? 0.306. Yeah. 0.0. Nope. Wrong shit. Wrong shit. Is it right? Oh, I forgot a 1 right there. My bad, guys. 0.561. I forgot the 1 right there. So that might throw my calculation off a little bit. Wait, I think I fucked this up. Hold on. Oh yeah, I did mess it up. Okay. Hey guys, I just thought of it. I had to move the decimal 2 points. So it's actually what was it? Move it once, 1, 2. No, move it twice, 1, 2, because it's 100%. Okay, yeah. So instead of being, so it's actually 0.1527. Okay, guys. My bad. This is what happens when you don't have a calculator and none of that bullshit. All right. But it's still the same numbers, okay, guys? Now we got to solve for 306. All right. So we got 306 of H2O, right? Grams and grams of CO of H2O. So hydrogen weighs 1. 1 times 2 is 2. 16, 16, 17. So 18. Oh, shit. 18 grams of water weighs 1 mole of water. And then 1 mole of water has 1 mole of, sorry guys, H2O. My camera went down real quick. Hold on, guys. Oh, we can still keep working. Fuck the camera. All right, so it goes 1 mole of water, right? That looks fucking terrible. Let me erase that. All right, so we're just gonna continue down. So right here, we're gonna continue going, okay, guys? We're just gonna continue going. And then 1 mole of water has 2 moles of hydrogen. How do I know? Oh shit. How do I know? Because if you look at H2O, see how this 2 is a ratio 2 to 1? There you go. Okay, that's how I got that too. All right, so you get 2 moles of hydrogen, and that we could keep on going. All right, so 1 mole of hydrogen is equal to 1.0 grams of hydrogen. You see that shit? And then that equals, so what are the numbers that we're gonna add or multiply and all that bullshit? Let me show you. So we're gonna multiply the 0.306. You know what? We don't need to put that grams. Times 2. Is that it? Yeah. Divided by 18 times just 1. Just divided by 18. All right, guys. So I'm not sure what this number equals, but if you guys could help me out real quick, that'll be badass. 0.306 times 2 divided by 18. So we got to solve that shit. Where's my calculator real quick? What was it? 0.306 divided by, oh no, wait, times 2 divided by 18 is equal to 0.034. Sorry guys, I just wrote it down real quick. All right. Yeah, perfect. All right. So now we got 2. Hold on. Let me get the camera working again. Hold on. But we're doing it right. So this is equal to hydrogen, okay? So where's that problem? And then this one is equal to, what was it? 0.034. All right, let me copy this one. Okay, there you go. So you see that? So this is where we're at right now. Hold on, let me get the camera on if I can real quick. Oh man, come on, please work. Like I say, I really appreciate you guys being here. Fuck, I've been at this for an hour and 30 minutes. Okay, there you go. All right, bam. All right, let's go back. Oh wait, where's our problem at? Oh yeah, this is our problem. Okay, there we go. Here's what I'm looking for. See, this is the original amount that we gave us, that they gave us. All right, so you see a combustion of the alcohol produces 0.225 grams, or I mean 0.225 grams of that shit combusted, or whatever the fuck, gives us the numbers that we have right now. All right, so let's write that down. Let's write it down instead first. Hold on. So let's write down the number they gave us, which was 0.22 or 255. Hold on, guys. I'm just trying to do this real quick. You know what, let me close the parentheses real quick. Okay, there you go. All right, so we got the original number they gave us, right? And then we had to subtract these numbers right there. Okay, so we got 0.255 minus the 1.5 0.1527. You know what? They just call, yeah, fuck it. Let's leave it like that. Minus the 0.034. So remember, this is hydrogen and this is carbon, I believe, right? And now we're trying to solve for oxygen. Oh, we don't know oxygen. This one right here is hydrogen, oh wait, carbon, oxygen, and hydrogen. This is all three of them together. And then this one right here, this is just the carbon and this is the hydrogen, okay? And we're trying to solve for oxygen. Okay? See that? So now let's subtract that number. Well, these ones we're going to add it together. It doesn't matter if we add them or subtract them, whatever the fuck. Okay? You could even put a plus right there. There you go. It still makes sense. Okay, you see that? And then, man, I don't have a calculator. Hold on. Hold on, let me just go with my notes. 0.068 grams of oxygen. Okay, there you go. Yeah, perfect. All right, so fuck, dude. Okay, so we got the oxygen right, and we got the carbon, and we got the hydrogen right. See that shit? Now, let me rewrite everything. So, carbon C is equal to, I'm just gonna put an equal sign, fuck it. 0.1527. Hold on, guys. Just give me a quick sec so I can write this down. H is equal to 0.034. And then oxygen is equal to 0.068. Okay, perfect. There you go. All right. So now we're gonna go. Now we're back at where we're always at from the rest of the problems that we were doing earlier. All right. So now we're gonna divide everything by carbon's molecular weight, which is 12 grams of carbon is equal to 1 mole. You see that? And then same thing for the hydrogen. What is it? One gram of hydrogen is equal to 1 mole. And then for oxygen, 16 grams is equal to 1 mole of oxygen. And remember, you get these numbers from the periodic table, all right, guys? And we're almost done, guys. I'm fucking tired also. Okay. Oh, man. See, this is why I need a calculator and I don't got one. All right. So let me just go over what the notes say real quick. My notes say, fuck it. All right. So for the carbon, we get 0. Oh, shit. 0.0128. So 0.0128. And for the hydrogen, we get 0.0340. And then for the oxygen, 0043. Okay, there you go. All right, fuck it. There you go. Those are the answers, all right? And then from there, hold on, let me do this shit real quick. All right, so from there, guys, you want to divide this number by the smallest one from out of all three. Okay. All right, and then remember, this is for carbon, hydrogen, and oxygen. Okay. The smallest number to me looks like this number right here, which is the oxygen. Right. So this is gonna equal to 1. Now let me get a calculator real quick. Ah, fuck, dude. I need a different phone real quick. Or you know what? Fuck, let me use my notes real quick again, guys. My bad. All you know what? Fuck it. Let me just grab. Let me just use the calculator right here. 0128 0128. All right. So the first one I got 2.97, which is close to a 3. All right. And then for the other one, divided by I think this was it, right? Shit. Equals 7.9 7.9. All right, there you go. All right, guys, fuck. So what does this mean? All right. So we got these numbers, right? All right. So what does that mean? You know what? Let me erase this shit. I don't really want these numbers there. No shit. I'm getting a phone call. Fuck them. All right. So you get these numbers, right? So now we're gonna write everything back out again. Oh shit. So now we're gonna write CHO, right? Again. So now we're just gonna plug in the numbers we got. So oxygen is 1, and then carbon. See how it's really close to 3, right? And then hydrogen. See how it's close to an 8. And then this should be our answer right there. Hopefully, it's fucking the right answer. And another way to check is to go look at the book because we got it right there. Okay, yeah, it's right there. Hold on. Bam. All right, so there you go. I'm looking at the answer right there. And there's our answer, C3H800. See that? That's the final answer. The same thing we got. Bam. All right, so that's the same thing we got. All right, see that? We do got one more problem to do. Fuck, I don't know if I should do it right now or next time, but I think we might go do it right now. So people are already calling me and shit. But what do you guys think? We should keep going, right? Thanks, brother. I have to go back to work. All right, G, do your thing, bro. Big MF, keep going. All right, then, G. All right, just know that this one, I'm not gonna have. ¿Cómo se dice? We're not gonna be able to use this as a guide or anything. So we're gonna really solve this one. So this is the moment of truth. So no matter what, here they gave us the answers at the end. Oh shit, they gave us the answers at the end, but like I said, we got to get to them. All right, so let's read the problem and then we'll get the notepad out. Oh, there you go, even better. Bam. All right. So this is why guys, really important to go with the book because they actually give you answers. And the book is never gonna give you trick questions because they're trying to teach you chemistry, not how to fuck you over. You know what I mean? Just think about that. All right. So next up, practice exercise. Capronic acid. I don't know how to pronounce it. CAPROIC. Oh no. Caproic acid, which is responsible for foul odor and dirty socks, is composed of CHOI, carbon, hydrogen, and oxygen atoms. Combustion of 0.225 grams sample of this compound produces 0.512 grams of CO2 and 0.209 grams of H2O. What is the empirical formula of capronic acid? Capronic acid has a molar mass of 116 grams per mole. What is the molecular formula? All right, guys. So they really they really want to fucking do us bad on this one. So on this problem, we're gonna have to do everything that we just learned and reapply it. All right. So first up, let's just write down what we know. So we know everything's composed of. Oh shit. Let me get the notepad out before I start. So we know everything's composed of carbon, hydrogen, and oxygen. That looks terrible. All right, there you go. And what it's saying is, all right, they gave us an initial amount. So let me write that down also, which is not important right now until a little bit later. All right. All right. So first up, we got 512 grams of CO2. All right. So when they ignited this in a fire or something, it produced 0.5 oh shit 512 grams of CO2. All right. So let's solve that one first and then we'll go back. All right. You know what? No, fuck it. Let me just write down everything. So they gave us CO2 on that. No. I'm wondering how I'm gonna do this. Yeah, let me just write it down again. The other problem. All right. And we got 0.209 fuck it, 29 grams of H2O. All right, so this is after the reaction, but this is why I kind of didn't want to copy. I mean, why I wanted to separate it. All right, there you go. Okay, there you go. Because I need to erase one to continue the problem. All right, so we got 0.15 grams of CO2, right? So now we're gonna get the molecular weight. A carbon is oxygen is 16 times 2 is 32 plus what 12. We're at 44. So 44 grams of CO2 is equal to 1 mole of CO2. All right. And then 1 mole of CO2 has 1 mole of carbon. All right, we're going to continue on with the problem. And then 1 mole of carbon in the bottom is equal to 12 grams of carbon. Okay. So what does that equal? This is going to equal to 0.512 times 12 divided by 44, which equals, all right. I don't have a number right now. Hold on. All right. Oh yeah, actually I did write the notes down. It's equal to 0.1396. All right. So we're going to take that 0.1396 grams of what is it? Of carbon. Okay. Hold on, my bad, guys. It's hard to keep track of shit. Okay, there you go. There you go. All right, so we solve for carbon. You see that, guys? So we have the carbon right here. You know, let me copy this slide. All right, so we got the carbon right there. Now we got to solve for the water. All right, so we got the carbon. So let me erase the carbon now. Oh shit. And now we got to solve for water. All right, so now let's do the same shit now for water. So water, I know oxygen is 16 and hydrogen is 1, so 16, so 18 grams of water is equal to 1 mole. Damn. So it's equal to 1 mole of water. And 1 mole of water has 2 moles of hydrogen. And then 1 mole of hydrogen weighs 1 gram. All right, see that? And what that's going to equal to is 0.209 times 2 divided by 18, which is going to equal to, hold on. What that's going to equal to, let's see. Uh, 0.02322 grams. All right. Bam. All right. See that, guys? All right. So now we got the grams right here and grams right here. And we're going to subtract it from the initial right there. Okay. And so what does that look like? So it's going to be 0.225 minus 0.1396 minus 0.02322. Bam. All right. And that's going to equal to that shit's going to equal to 0.06218 grams. Yeah, grams of oxygen. Bam. All right. Let me see something real quick. All right. And then oxygen was, what was it? 0.06218. Okay. So we got oxygen, hydrogen, and carbon. You see that, guys? So now we're going to take this side of the equation, and we need it right now for 0.1396, 0.02322, 0.06218. All right. So now we're going to divide this by the smallest one of all of them, which is the oxygen. So this is going to equal to 1. Oh, wait, well, what the hell am I talking about? Hold up. Nope, I'm a lie. That's a lie. You don't do that shit right now. All right, so now we got to take the now we got to keep breaking this shit down even more, guys. All right, hold up. All right, so now 12 grams of carbon is equal to 1 mole of carbon, and then 1 gram of hydrogen is equal to 1 mole of hydrogen, and then 16 grams of oxygen is equal to 1 mole of oxygen. So now we got to figure that out. Fucking bitch. Oh yeah. I'm right. So it's gonna equal to 0.00388. Fuck, that's not gonna work out. Point 0.0038886. Damn. Hold on, guys. I'm getting a call. I'm getting calls right now, and I gotta keep going. All right, hold on. And it says what happens if we don't have a calculator. 0.02 322. And this one's gonna equal to point 0.01163. Bam. All right, fuck it. All right. And so now we're going to divide by the smallest number right now. All right. So we're going to divide by the smallest number, which I think it's the oxygen. And this is going to equal to. So divide all these numbers by this number. Divide all those numbers by that oxygen. So it's going to equal to 1. And then 5.975. And this one's going to be. Bam. All right, there you go. All right, so when you divide those numbers by the bottom right there, you're going to get those numbers. So remember, you're dividing all these numbers by the smallest one, which is this guy. All right. And that's how you got 1 automatically, because you're dividing by the same one. And then do it to all the other ones. And you're going to end up with, again, let's write down what we're solving for. So oxygen, hydrogen, and carbon. Oh, wait. I got them mixed up. So I got carbon, hydrogen, and oxygen, right? So carbon is this one right here, hydrogen, and this is oxygen. So we just got to plug in the numbers. So nearest whole number is going to be a 3. On the H is going to be a 6. And the oxygen is going to be a 1. So here's the, what do you call it? The first weight that they're asking for. I forget between the molecular weight and the empirical weight and all that bullshit. All right, hold up. Where are we at? Oh, yeah. So right there, right? So that's where we're at. And so now it brings us back to where our first problem. Oh, shit. That's not it. Okay, so yeah, so the original problem, remember, guys? So remember, originally they gave us this is the original amount they gave us right there, the 0.225. All right. All right, so they gave us, what was it? 0.225 grams, right? Hold on, guys. I'm fucking this shit up. Oh shit. Hold up, real quick, guys. Fuck. Oh yeah, yeah. Sorry, guys. I'm all tripping out. I'm all tripping out. I'm all tripping out. We don't need that. This one right there. Okay, now I know. Now I know what I'm tripping out on. All right, so we got this number right. This formula right here. All right, so now we got to do what we were doing before. So we got the 3, and then the carbon, right? Carbon is 12 plus we got 6 hydrogens, and hydrogen weighs 1, and then we got 1 oxygen, and oxygen weighs 16, right? And then what this is going to equal, on my notes, I got 58. Hold up, is that right though? Yeah. Has 58. There you go. So this is going to equal to 58. And then if you look at the original problem, I was looking at the wrong problem. So if you look at the original problem, oh fuck, I lost it again. Oh, there you go. It says it has a molecular weight of 116 grams per mole. All right. See that? So what that means is that equals 116, right? Grams per mole. And right here we got 58. So now we got to divide this number by right there. So 116 divided by 58 is equal to what? Let's find out. It's like around 2. There you go. It is equal to 2. All right. Now we got the 2, right? So this 2, we're going to multiply it by that formula that we just got right now, which was what? C3 H6O1, right? So maybe write it C3H6O1. So this is equal to 58. And then we got 116 divided by 58 is equal to 2. Bam. All right, you see that? And now what we want to do is get this 2 right here and multiply it to all these numbers right there. All right. So this is the answer to the first part of the problem, and then the second part of the problem, we get C3 times 2, H6 times 2, and O1 times 2, and that's going to give us C6 H12 O2. Bam. All right. Now, if you look at the problem, there we go. It's right there. There you go. So we got all of them, right? Remember the first, that's answer to 2, and then the first one was divided, was C3H12 oxygen 1. There you go. And those are the answers right there. You see that? Right there. Bam. And guys, we're fucking done because I'm tired. I don't want to continue no more. And we made it as chapter 3.6. Bam. All right. So we made it into quantitative information and from balanced equation. Fuck. Oh man, that shit sucked, but it was important. All right, guys, we finally did that shit. Now remember, all this is really important, and I'm trying to remember this shit on the go, and just as well as you guys. But we're there, and we finally solved this shit, and we're ready to go on to the next problem or the next section of the book. But we're gonna end it there because it's a 2-hour live, and goddamn, just to do just 1, 2. So going from page 98, flipping 2 pages. I mean, from 95 to 98. That's only 3 fucking pages, man. 1, 2, 3, and it took us 2 hours, and most of it was just math. It was barely reading. Welcome to chemistry. It's only gonna get harder because even though you see words right now, eventually you're not gonna see no words, and you're just gonna see math, and you're gonna have to really follow what we're doing. But anyways, Big MF, hey bro, thank you for joining, bro. I didn't know you were still here. I'm glad you were still here, bro, watching for the last final problem, and then we'll start off on 3.6 next time and all that. But man, I'm tired, and these are all my old notes from when I was first learning. So if they're wrong, I'm gonna catch it, but at the same time they should be right because I did them a long time ago, over 10 years ago. But anyways, much love to everybody that tapped in. Big MF, thank you for joining. Aquatic, Coral, Rainer, and everybody that joined in. Thank you guys for tapping in. Yeah, everybody that tapped in, much love. See you guys on the next video, and thank you guys for your patience and all that. All right, much love.